Hey guys, I'm Volan, and in today's video I will show you how you can make your own GDE extension which uses FFmpeg. I'm keeping this introduction short because there's a lot to go through. In this episode I will show you how you can make the actual GDE extension and import FFmpeg with it, with dynamic linking. In the next episode I will show you how you can import videos. And in the next video after that I will show you how you can render out videos, and that all within Godot. Now I'm using Linux, more specifically Arch Linux. I use Arch, by the way. So some things may be a little bit different if you use Windows, but it should not differ that much. I will talk about the parts which you should probably do differently when you work on Windows. And for the Mac users out there, bad luck, I don't have a Mac and I have no idea how that stuff works. But I guess same like the Windows side, you'll probably be able to figure it out how it works if you know a little bit about C++ compiling. So first up, let's create our basics. So I created a new folder, I opened VS Code. One of the things that you will need is the C++ extensions. Another thing you should probably have is Python, and you should normally be able to do pip install Scons, because that's how you build the GDE extension itself. Some other requirements is install FFmpeg. So if you look at FFmpeg, we have the normal one, and then we also have the 4.4. We'll be using the latest one, so it's just FFmpeg. If you use Arch Linux, for other systems just install FFmpeg the way that you would normally install it on your operating system. Yeah, that's basically all you need to do for that. If you want to be cross-compiling on your Linux system for Windows, by example, you will also need mingw, basically all of them. When you have those installed, you will also need to clone the FFmpeg Git repository. So basically this Git repository, you copy it to your system, you do the whole configuring things to make install it towards the mingw folder, and then you should normally be able to cross-compile. I don't got it working, but that's mainly because my system only has 100 gigabytes of storage space for programs. And I don't feel like uninstalling the whole Android toolkit again, so yeah. So that's some of the things that you will need if you want to cross-compile for Windows on Linux. For Windows users, you don't have to worry about those things. And then the next thing that you will need is the actual code to generate your GDE extensions with. So go to the Godot-cpp, C++ repository, code, SSH, copy, open the terminal, git clone. Let's paste that in, and normally that should be loading. Can take some time, it's kind of a big one. Okay, I lied, it goes fast. So you have the test folder. If you are completely new to the whole C++ stuff and such, and the whole GDE extension stuff, maybe take a look in here to like see how everything actually works. I did not actually know, but apparently they have the tools for so the XC framework, that's all Mac OS related. So that's all for, yeah. We won't need to worry too much about that. The only thing we need is creating this main folder, an src folder, source code, and also a bin folder in which all the binary files that you will generate will arrive in, be compiled towards to. Now I'm setting this up quite easily. A better way of doing this is actually create a git structure, git branch and master, whoops, and add a git submodule. So that will be a better way of doing it. If you look in the git modules, you will also see it has the path, it has the URL. This will be an easier way if you are actually planning on keep updating this whole structure, this whole system. If you're using this tutorial for your own application that you will use for multiple months. So that's probably the better way to go about it, to just use gits and git modules. Next up, the Scons construct file, basically the file that you'll be using for actually compiling the whole program. Now I will not make a base version, I will kind of explain how the GoZen Scons script works. So you have more of an idea of how GoZen also works, but you can easily adjust it to your own liking. So let's create constructs. Whoops. So first I have a destination variable, and this is basically where it will be saving towards to. So the way that you could choose this is use scons j for your amount of cores, and then destination, and you put it to, for example, for us, bin. If I would run this, yeah, it would not work, of course. I still have not filled in the destination or any of the other code. So we get our arguments, dot get, and we need the argument for destination. And this is the default we set to bin. So if no variable is given, then it will use bin. We can easily test this by doing this. So if you use scons, it uses bin. If you use scons destination, voila, normally, so that works. Scons is basically Python, so you can just use Python functions like normally, like I'm using print right here. And now we need our environment. So maybe let's create a comment setting up our environment. Oops. I cannot type today. So environment, we create a construct. And now we need to link this towards the Godot-cpp, and this would also have a construct file. So Godot-cpp, and then constructs. And then another thing we will need is we need to get all the files from our source folder. So let's do that first, and whoops, append to the big A. CPP path. Oh, oops. Always between brackets, and then cpp path, and then we add our source folder. So now it will get all the Godot-cpp related stuff, plus all your own made source files. And now the part that kind of has to do with if you're using Windows to compile everything or using Linux to compile everything. So we will need to check if environment platform is Windows. Then we just print not implemented, and we exit. Now I'm doing this because I have not set up the whole Ming W stuff, so I cannot make this work on my Linux system. For the people using Windows, the only thing you need to do is adding FFmpeg library locations. So you will need to append all the paths to the environment. I don't know the paths for Windows related stuff. If you know, please let me know so I can put them in my own script on the GoZen stuff, on the GoZen-ffmpeg repo, because right now that's not really working. But basically what you will do is add a CPP path, and you will have to add them for everything. For people on Linux, those libraries for FFmpeg are mainly located in the user, include, and then, for example, libav codec. There are some other ones. These are some of the other ones. So AV format, we also need AV filter, AV device, AV util, SVScal, and SW resample. I don't know how you're meant to like pronounce those, but yeah, for Windows, the only thing you need to do is find out where the AV codec.sh file, .h files are located, and add those paths to the environment. It's just like this. So you will basically do this and then change this to anything. So probably on your C drive. I have no idea. Try to find where they are and then add them to this part in the same method that we do it for this, for adding FFmpeg library locations for Linux. Next up, we will need to actually include the files themselves, like the AV codec.h file and the AV format.h file. So for that we do add FFmpeg, libraries. I really can't type today. And then we add all of these. So we have the AV codec lib, AV format, and just use libs. This does not matter if this is for Windows or Linux. This will work. The only thing you need to do is make certain that the paths are correct. Then we need to make certain that the files actually get added. So we go src .cpp. And now I have two more difficult parts. So we need our library path of where we will save it and which name it should get. We will use string formatting, so lib GoZen. You can call this whatever you want, but because I do this as a tutorial series on GoZen itself, I will call it GoZen. You can use lib FFmpeg, lib video player, anything that you like. And then we add two more of these dot formats. And then first of all, the destination. We added this here. So destination, we get the destination. So normally it's bin. If it's not bin, then yeah, anything that you like. So yeah. So we put destination here. Next up, we need the environment suffix. Next up, the environment is 8 libs suffix. I think that's it. We'll see later if it's not correct. Let's just give a quick print to see if it's actually correct or not. So lib path. Oh, whoops. I suppose this one. So reading Scons files names construct is not defined. So this is not correct. Ah, no, Scons script. So that. So this should normally work now. So yeah. Oh, whoops. Yeah, it's actually compiling already now. So yeah. So let's quickly cancel. But we see bind td, so that the string that I used actually. Oh, whoops. Accidentally did it. So you should probably just remove that altogether because we won't need to set the destination manually, as bin is the correct folder for this use case. Bin libgozen.linux.template debug, and then the end result. For Windows systems that will be .dll and not SO. SO stands for Shared Library on Linux. So let's delete that. And next up, a shared lib environment.shared. Oh no, that's wrong. Shared library. For this we will need to use the lib path, so let's just put that closer. Lib path, and we use the source codes. And default shared lib. And normally if I would compile right now, I normally should get a file. So let's give this a quick go. Let's use as many threads as possible. This may take some time. Well, whilst it's compiling, let me go over this last part. Honestly, I don't really know what the last two lines do. I only know what this does, and that's basically creates the library path itself. This does take quite a long time. Okay, and we finally have our library file. So it worked, no errors, and that's basically it. The moment that you have this working, the rest is kind of more difficult. First step, let's go to our source folder, let's create a new file, and let's call it FFmpeg includes. Whoops. .hpp. In this file, let's first start with the boilerplate, pragma once, and then we need to use extern C, because FFmpeg is completely written in C. You cannot just include them like normal files. And then we go ahead and include libav codec, avcodec.h, and we basically do this for everything. So av format, av device, libav util dict. Anything that you see in here, just type it over, copy it over, and finish. You can find this file in the GoZen-ffmpeg repo. The link will be in the description. So after we have that, we need to create a new file called register types.hpp. So because we're working with the GoZen files as well, every class that we make, every function that we make, we need to register so Godot can use it. So you can use those functions and classes from the Godot editor itself with GDEscript. So again, pragma once, and then we need to include a specific file from the Godot folder itself, from Godot's Godot-cpp folder. So Godot-cpp, and then I think core class db.hpp. Maybe? Somehow this is not working. I think this is an underscore. Is it? And namespace Godot. Okay, yeah, no, okay, that works, okay. But not like this. Let's using namespace Godot. Godot? Small Godot? Small Godot. And then we need two functions to initialize everything and uninitialize everything. So void initialize GoZen library init module, and then module initialization level English, and let's call this p level. This is also basically from the whole test folder that I'm kind of copying stuff over to create a main boilerplate. And then we basically need the exact same but uninitialize. And let's copy these over and let's create a new file. Register types.cpp. Now we need to include the file itself, so include register types.hpp. Next include should be the includes GDExtension interface .h. Okay, I'm remembering it. Next includes Godot core devs.cpp hpp. Oh, and again, this is the /cpp. Copy and paste that line, make it into Godot, and again using namespace Godot. And actually, let's just copy this and put this in register types. Okay, so after copy pasting the initialize GoZen library init module, again you can rename GoZen to anything you like. After copying these two functions, we need to have an if statement. If p level is not module initialization level seen, then we need to return. And over here, normally we would go like register our classes. We don't really have anything yet, but it will look like class db, register class, and then here like GoZen interface, by example, or anything that you want. I'll comment this out for now because we will need this later anyway. Oh, and over here as well, we need these. And for initialize, it's actually quite simple. We can basically copy this, go in here and paste this, and that's it. But then we need another extern C part. So for people who are not very used to C++, it can be kind of complicated at times. And here we have our initialization. It's been a long day, a long busy week. And here we need a GDExtension bool, GDE exports, GoZen library init, and over here now it probably is better to copy paste this, but I think it's also kind of helpful to just type everything out a little bit. This is basically a function, so let's do this already because soon we won't have any space anymore. So we need a proc address. So GDExtension interface get proc address, and we call this p get proc address. Next up, we need the class pointer, the class. Let's see if I can find it. Class library. Yeah, okay. So the GDExtension class library pointer, and let's call that p library. And next up, we need the initialization. If I can find it. Okay, over here. And this is a pointer, so let's use this one. And let's call it initialization. Okay, and I think that should be correct. So the whole setup, it's kind of a long and complicated one, so sorry about that. That's just how it works. To be very clear, I'm taking the long and explained route to like show you guys this. It can be easier by just copying and pasting the test file, but doing it this way you have more of an understanding what you typed and what every part is and does, hopefully. Next up, we need to Godot bind extensions, GDExtension binding. We need to create an actual object. So init object, and over here we need to basically pass almost all the variables. I think all the variables. So we need to let's take a look. Nope, it does not work. The definition. So we need the proc address, library, and initialization. So the way that I do this to get the information, I just go to Go-definition or the F12. So basically, we get proc address, p library, and our initialization. Voila. And then the next part, we're almost done. Only 3 more lines for this part. I actually forgot to give this an actual name. So init object, and then we go init object.register. Register initializer, and then we go to then we use the function, so the one over here. Voila. Yep, that works. Okay, almost done. Init object dot register terminator. So that's basically an initialize Gozen library init module. I'm starting to speak more fluently. And then init object dot set minimum library initialization level. I don't quite remember what this has to do. I think it's the on which level it's supposed to like actually work. Scene level, editor level. So let's type scene and hope it pops up. Okay, module initialization level scene. And because this expects, like this is a function that returns a GDExtension bool, we need to return the init object dot init. If it cannot init, it will probably return false. So yeah. So this works, hopefully. So let's compile one more time. Normally we already did the compiling once, so it should not have too much work. Only add new files. Voila, that's already done. You will see some extra files appear for people who are not familiar with C++. Not too difficult, and our bin folder should have the template debug. And let's create a new file, and let's just call it test. So test test.hpp. Again, pragma once using namespace Godot. Let's make one include. So includes again Godot-cpp. The folder is called with a line in the air. This one is called with a underscore, kind of confusing at times. We take variant and then I think utility functions, and that way we will be able to have access to the print functions, by example. And also a quick test to see if FFmpeg actually gets included properly. We can do includes FFmpeg includes.hpp. And now we will need to create the actual class. So class, let's call this just Gozen-tests, of course space. We need to make this into a public. I think we can leave this empty for now, and I think class should be with a small one. Yeah, no, we actually need to do this as a resource. I think I was struggling with that in the beginning as well, and this was like the easiest way that I found to actually make things work. So includes Godot-cpp classes and then resource.hpp, and normally this should work. No errors, that's good sign. So we add gd class, Gozen-tests, and a resource. And normally that should remove all the squirrely lines, and it doesn't. Gozen has no member bind methods. Okay, so let's fix that. So let's create a protected void binds methods. I think we should call this an inline void, if I remember correctly. Probably even better a static inline void. And over here we will do basically the same thing as, oh, I should probably keep this one open. So over here we use class DB, over here we also need to use class DB, so class DB. And then you can see binds, you have bind methods, bind static methods, binds argument, yeah. There's a whole list of how, like even enums you need to register all separately. I'll show that later. So bind a static method because we will make a static method. Let's comment this out for now so we don't see the error. And let's quickly create a public static inline void, yeah. Print tests. Okay, so I use it as an inline so I don't have to create a .cpp file, then I can do everything in the header. For this use case, for this quick little test, normally it should not be a problem. So here we include the utility functions. So this will allow us to actually use the print function. So print and test succeeded. Okay, but now we need to bind this thing to the class, and let's remember the structure of C++ files with the column at the end. So over here we need to add a D method if I'm correct. I think this should be a string, and we need to create a pointer to the GoZen tests and then print test. I think that's how you register functions. It gives an error. Okay, so no instance of function template Godot class bind static method matches the argument list. Okay, let's take a look at the thing itself. So string class name, method method. This is saying that I need the P class and like the string name of the class. So let's try that. So that will be GoZen tests. This should work. Why is it still saying, oh yeah, I expected a column. Okay, so normally this should work, so let's quickly, quickly compile it. Normally this should take a lot less time. Okay, it's already built. And now let's open, let's create a new folder and call this Godot project. Let's open Godot and actually create a project inside of it. So let's create a new project. Let's go to the correct folder. So for me that's storage, programming. Anything is fine. Let's just remove the version control and create an edit. So the only thing that we need to do right now is just create the actual file. Let's close this. So something that we could do now is we can actually use destination. We go to the Godot project and we create a class in here called, we create a folder in here called bin. And if you do this now and compile it, normally it should create the, normally this should work. No. And if you do this, scons -j, so just Godot project bin, this should work. Okay, so I probably have a libgozen folder file now in another directory. Okay. So yeah, now we need to go into this. Let's create a new file and let's call it libgozen.gdextension. Let's open this. Let's just call it GoZen interface because that's how I'm calling this inside of GoZen-ffmpeg anyway. So now this is basically the config file that gives all the information to Godot, so Godot knows how to load in your GDExtension. Now we start with typing configuration, configuration, and if you go back into our register types file, we have GoZen library in it. Basically, this is the function that will be able to call the initializer, the initializer. So we need to set this path, function name, our entry symbol. So entry symbol is GoZen library init, or again, whatever you name this file. Now we change the compatibility limit, and we set it on 4.2 because Godot 4.2. And then we add libraries. For people using macOS, you also have to add dependencies. I'm not going to do that stuff because again, I don't have Mac. I am not 100% confident enough to like say like it works like that on macOS. No idea. Same for Windows. I can kind of give the guidelines for Windows users, but it's programming, so you'll still have to figure it out yourself in the end. So we add our Linux debug.x86 and then 64, and we get this file. So copy relative paths. We don't need this one. So bin libgozen.linux template.x86 underscore 64.so shared library and shared object. And normally this should work for Linux, for Windows users. You will have to add Windows, and this should also be Windows, and this should be DLL. And basically, if you want to have the release version, let's quickly do this. So we call this release, and normally this should work. So, well, I say normally, I always run into things that I think like, it will work now, and it's supposed to work, it does not work. So let's create a new scene. Let's quickly select current scene, control, let's do, I'll do this quick setting so it does not mess up too much with my tile layout. So resizable. Okay, so normally if I start this will just be a floating window, so it doesn't bother me. Okay, and that works. But I'm seeing here, so config file parse error adds when unexpected identifier GoZen library init. So something is not correct right now. Make sure resources have been imported by opening the project in the editor at least once. So let's see if it works or not. So func ready, and normally we should be able to use GoZen. Oh wait, we forgot one part. Okay, inside our source folder, the register types. .cpp. We actually forgot to register the class itself, and that's something I talked about before. So GoZen tests, and normally this should work. Oh yeah, we also need to include it. So let's go over here. Includes test.hpp. Okay, so normally this should still compile. And maybe Godot will stop complaining now. Still complains. It failed to load in the script. Let's quickly add a pass here. Test.print. Print tests. Why is this not working? Okay, I'll probably need a second. I'll be back. Okay, and I'm back. And first of all, let's put this between brackets. Next of all, we need to actually define the path properly because it's in the res folder. It's not just in a folder called bin. And also I did a small mistake here by putting a underscore here. That should be a dot. And also in the test file itself, we should probably have an initializer and an uninitializer. Probably not needed that part, but could help. So let's compile one more time. Let's load up Godot, and let's hope it stops screaming this time. Good sign. Also, it's being recognized. And it does work. Oh. Finally. And this is how you can create your first GDE extension with FFmpeg included. We have not touched any of the FFmpeg functions altogether. But that's also for the very good reason that it's very complicated, and that's why I'll put that in the next video, because recording time of this video is already over an hour. So thank you all for watching. If you like this video, please click subscribe. If you want to follow this channel, this journey of making a GD extension, about making a video editor in Godot, please click subscribe, and I'll see you all in the next video in which I will show you how to actually import videos of all video formats, all video codecs inside of Godot. And before I go, a quick mention to all my Ko-fi supporters. Thank you very much. Without your help, this would all not be possible to keep doing. So thank you, very big thank you, and I'll see you all in my next video. Bye bye.